So we've just gone through all that stuff on implicit derivatives, all those nice big equations. Well, then let's go to something simple then. What's the derivative of f of x equals 2 to the power of x? And so we got f of x equals 2 to the x. And of course, that's the same as y equals 2 to the x. The f of x isn't changing anything, but the 2 to the power of x is changing something. Well, I'll give you a hint on this one. The answer is not 2 to the power of x when we do the derivative.
I know what it is.
It is not. There's actually an extra wrinkle in there. And I'm going to save you all the grief of going through a derivation and all that stuff today. I'm going to go ahead and just give you the notes on what it is. So, into your derivative rules, please add this rule, and then we'll talk about how it gets used. All right, so notice what we have here as our rule. We have d over dx. Remember, of course, we don't use that notation a ton. We're usually using prime notation, but you have to be able to use both. That just means derivative of a to the x equals a to the x, yes, times the natural log of a. So that's ln of a. So notice, whatever this number is, notice it has to be a number to the power of x. That number is what goes inside the natural log. Okay? So, what would the derivative of this be then? Well,
2x log
f prime of x would equal, well, the 2 to the x part is still there, but we need to then multiply it by the natural log of 2. Now, the way I wrote it here, it's correct, but it doesn't look as clean. For some of you looking at this, it might be a little bit more confusing. So if you want to put parentheses around that 2 to make it clearer, by all means, do so. That's a great way to make your natural logs look clearer. Or, if you want to put a multiplication symbol in there, so that it doesn't blend in with the 2 to the power of x, feel free to do so. Or, if you just like writing the natural log first, and then writing your 2 to the power of x, that would also be fine. Of course, they're all the same, and there's nothing particularly picky about any which way to do it. Now, I want to add in one more layer to this. So we figured out what f prime of x is here. What is the second derivative of x?
Understand.
All right, so notice, if I want to find the second derivative, I have 2 to the x times the natural log of 2. Now, the natural log of 2, though, that's not a function. Well, not really. It doesn't involve x anywhere, does it? It's a constant. The natural log of 2 is just some decimal that we haven't calculated yet. And so, when I find the derivative of this, it's going to be the derivative of 2 to the power of x again, which is 2 to the x natural log of 2. And so that is this times just the natural log of 2, because it's just a constant. We don't have to use some fancy rule or anything like that. It's just times the natural log of 2. Now, of course, right now that looks kind of weird, right? Because we've got a couple natural logs of 2. So let's clean it up a little bit. It'd be 2 to the power of x times the natural log of 2 squared. The other way some people do it is product rule, but I want you to see that it does give us the same thing. So if you'd done this by product rule, we would have gotten up here the derivative of 2 to the x, so original times derivative, so that'd be original 2 to the x times the derivative of natural log of 2, but the derivative of natural log of 2 is 0. Plus derivative times original, and so the derivative of 2 to the x is 2 to the x ln of 2 times the original, which was ln of 2. So you notice, so I run out of room here to write, you'll notice it gives us the same thing because 2 to the x times 0 ends up being a 0. We don't have to use product rule when it's a constant, because it just zeroes out. Now, we just learned a new rule for finding the derivative of an exponential function, but we already have been able to find the derivative of this one.
Oh, because...
Are those different rules? Do they conflict?
No, they're the same.
Take a moment, show how you'd find the derivative of this, actually using today's new rule. So, if we're going to use today's new rule to find this derivative, we'd do f prime of x equals that e to the power of x times the natural log of e. But e, remember, of course, is a constant, not a variable. And the natural log of e equals 1. So it's actually e to the x times 1, which of course is just e to the x. So that's why that particular rule works the way it does, and why e is so unique like this. Because the derivative is its original function, but it's just this one particular case of the more general exponential derivative. So for that first one, we have 4 to the power of something. It's 4 to the power of a function. So that tells me I'm going to have to use chain rule, because we have this as the inner function, and the outer function is 4 to the power of something. Well, let's start with the derivative of the outer. So that's going to be 4 to the power of the same thing, ln 4. So you got to remember the natural log piece in there. But still, we got to use chain rule. So that's the outer function. Now I need to do that times the derivative of the inner function, the derivative of 3x plus 5. So that's just 3. Well, there's your derivative. I mean, if you want to, you could reorder it a little bit to maybe make it look a little cleaner. Maybe you want to put your constants first. But it's the same thing. So that one's looking good. That's all we got to do. All right, now for the other one. F of x equals 5 to the power of sine of x. All right, for this one then. F prime of x is going to equal derivative of the outer function. So that's 5 to the power of sine x times the natural log of 5. And then that times the derivative of the inner function. And our inner function here is the sine of x. So the derivative is cosine of x. And so there's our derivative. We're done. And again, if you want to reorder it in a way that maybe makes more sense to you, maybe you like the natural log of 5 first, feel free. But that's just a style thing more than anything. Our derivative is done here.
Doesn't change anything.
So first thing we got to do is find our derivative, because this one's looking for tangent, and tangent, of course, always tells me to find the derivative. So to find y prime, well, notice we got a function within the function. So that power of 10 is our outer function. Did you notice here, we don't need today's new rule for this. There should be no natural log in your answer. And that's one of the reasons why this comes in at this point, because it can be really easy when you first learn something to think, okay, I got to apply it to everything now. But no, actually look for it. We only use that new rule today when it's to the power of x. When x is in the bottom here, we're just going to use chain rule like normal. So it's going to be 10 times 2x minus 1 to the 9th times the derivative of 2x minus 1, which is 2. And so y prime just equals 20 times 2x minus 1 to the 9th. All right, now that we have that, I now want to know what the slope is at this point. And so to find that slope, I'm going to plug that point in. Notice this is an explicit function, so we only have to plug in the x. It's not one of those implicits where we've got to plug in x and y. And so we do that math. 2 times 1, of course, is 2. 2 minus 1 is 1. And 1 to the 9th is 1. So m is 20.
Oh, never mind.
Because we're just doing 20 times 1. All right. You now know your slope. Finish finding the equation. All right. So we know that we're going to have y equals 20x plus b. Well, plug in your point. Plug the y coordinate in for y, plug the x coordinate in for x, and then solve it for b. So 1 equals 20 plus b. Subtract the 20 from both sides, and you find that b equals a negative 19. Therefore, your equation is y equals 20x minus 19. And you're done. That's your final answer for the tangent line, equation of the tangent line, to the curve at that point.
I did it right.